Hey guys, Mrs. Traver here. We're going to get going on our notes for sections 4.1, 4.2. This is exponential growth and decay graphing. There it goes. I started us up a little bit here so that we could kind of jump forward in our video. I'm going to turn on our flashlight. Okay, good. So I'm going to kind of walk through what I've got already on the page for you, and then we'll move forward to doing some graphs from scratch. So first thing to notice, this is our transformation function equation. Y equals a times b to the x minus h plus k. And some of these variables might look familiar to you. We've got h, which affects x left and right, as well as a, which compresses, stretches, and reflects the graph. We use this to multiply by y. And then k, which we add to y, and it tells us what we're doing up and down. Then our new one is b, that's the base. That's what's to the x. It tells whether the function is growth or decay. So let's look at each, the growth and decay. So in this one, if b is greater than 1, then our function is going to go up like a growth. And if b is in between 0 and 1, like a fraction or a decimal, then it's going to go down like decay. And then I've got in here for us a couple points. 0, 1 is a point in common with our parent functions. And then 1b is another point that's in common with our parent functions. Notice this 1b, it's greater than, like the height here is 1 and the height here is b. So b is greater than 1. And here the height is 1 and then the height is b, so b is less than 1, which is exactly what our constraints were. The next thing that's slightly new about these is that they've got what's called an asymptote. So an asymptote is a boundary line that the function cannot cross. So in each of these parent functions, the boundary line is the x-axis, and it's actually found by looking at the equation wherever k is, which in our transformation functions, it will be a different number. But for our two parent functions, in this case, each of these equations is y equals b to the x. And we have nothing getting added to it. So since there's nothing right here, k is 0. So our asymptote line here is the line y equals 0 for each of these. But if that number changes, then that'll change as well. So our boundary line is the line that the function can't cross. It's the line y equals k. And that's helping us to see like where we can draw our function and where we can't. So we'll use that when we draw our functions. The last thing to look at is domain and range. So domain is nice because it's always going to be all reals. Notice it's where the x's can touch, and they touch everything from left to right on each of these equations. And then range is helping us kind of get range is our asymptote line. So knowing, for example, in this decay function that this is the asymptote line and our function can't go below it, basically what we're saying is our function has to stay above it. So greater than k, y greater than k will be our range. The only case it isn't y greater than k is if it was reflected when a is negative. In that case, it would go below, and then it'd be y less than k. So let's look at some of these graphs and see what's going on. The first two we do will have no transformations done to them. Those be straightforward. So let's check those out to start. We've got the equation y equals 2 to the x, which is a growth function because our b is 2. So let's get ourselves started. We have the 2 points, 0, 1, and 1b, which b is 2. So those points are always going to be in it to start. And then when we do more transformations, we'll kind of start with those and then see where we move. But for this one, we have no transformations, so we can just put them right in. And then let's look to the left and to the right. So if I plug in a -1, I've got 2 to the -1, which is 1/2. If I plug in a 2, I've got 2 squared, which is 4. If I plug in a 3, I've got 2 to the 8th, 2 to the 3rd, which is 8. And then let's plot these. So -1, 1/2. 0, 1, 1, 2, 2, 4, 3, 8. And then we also have our asymptote. So before I bold in my line, I like to draw my asymptote, which there's no k here. So it's the line y equals 0 is our asymptote. Usually, by the way, we draw this in with a dashed line, but because it's on the axis, it's kind of hard to draw a dashed line over a line that's already there. So I like to use a highlighter. And then I'm just going to get this close to, but hopefully not touching that axis, and then kind of follow it up. So there's our first exponential growth graph. Let's lastly look at the domain and the range. So our domain is everything from left to right, all reals. And our range is everything above our boundary, so y greater than k, so y greater than 0. All right, let's look at the next one. This one has a b of 1/3, so it's a decay function. And let's use the points 0, 1, and 1b again, where b is 1/3. All right, let's look at 1 point to the left and the right, or 2 points to the left. So if I plug in a -2, we gotta be pretty good with our exponent math here. So hopefully those are like already good for you. But let's do one out on the side to see how it goes. Oops, upside down. So if I had 1/3 to the -2, I can flip it and make that be positive. So really it's just 9. So flip it and then square it. So 1/3 to the -2 is 3 squared, which is 9. 1/3 to the -1 is just 3 to the 1, which is 3. So just flip it. So hopefully this is stuff you can get from here to here kind of in your head without having to do a bunch of side work, because we don't get a calculator when we take this quiz. So you got to be feeling good about your exponents at this point. Lastly, 1/3 to the second is like 1/3 times 1/3, so that's 1/9. So there we go. We've got our points. So -2, 9, -1, 3, 0, 1, 1, 1/3, and then 2, 1/9. That's just getting like really close to the line. I don't really care what decimal equivalent 1/9 is. The next one would have been 1/27. It's just getting really close to this line. But it's not going to touch our asymptote line, which again is at our axis because we haven't done any shifts yet. So I'm getting really close to this line, y equals 0, but I'm never going to touch it. Oh, kind of touched it. So there's our graph. Domain and range. Domain, all reals, all the time. Range, everything above our boundary line, so everything above the asymptote, y greater than 0. All right, let's look at the next couple. These ones do have some shifts involved. So 3 and 4, there will be one transformation happening, and then 5 and 6, there'll be 2. So let's see what's happening on number 3. First off, to notice we've got 2 to the x, so our b is 2, and we've got a growth function. And the 3 is an a, so we're going to have to multiply y by 3. It's going to stretch it. So let's jump in. In our parent function, we have these points 0, 1, and 1b. I'm not going to put them into our table just yet because we want to see what's going to move with them. Notice because there's no, let me rewrite, I'm going to rewrite this up here. Notice because in our function there's no h with the x's aren't getting affected at all. So I can use the points 0 and 1 in those spots. And then 1b, those are the y values, and the y values are going to get affected by our a by being multiplied by it. So it'll go 1 times 3 is 3. And then b, which is 2 times 3 is 6. And then let's check some points to the left and right. So -1, -2, 2. So at -2, 3 times 2 to the -2. 2 to the -2 is 1 over 2 squared, so that's 1/4, so that's 3/4. 3 times 2 to the -1, that's 3 times a half, that's 3/2. 3 times 2 squared is 3 times 4, which is 12. And there we go. We can plug in. So we've got -2, 3/4. -1, 3/2, that's 1.5. So -1, 1.5, 0, 3, 1, 6, and 212. I don't know if that's on the graph. Oh, it is. I think that's 12. All right, so there's all my points. And then we've got an asymptote where there's k value, which there's not a k value, so that's right at 0 at the axis. So there's my asymptote, y equals 0. Here's my growth function. And then lastly, let's look at domain and range. Domain is everything, all reals. Range is everything above our boundary line, so everything greater than 0. So y greater than 0. Our next one, it's got a 1/2 in there, so that means it's a decay function because our b was 1/2. And also it's got a +3 up here. That's an h value. So we're going to move, it says +3, so we're going to move left 3. So when we work on it, we'll subtract. So our parent function was 0, 1, and 1b, but let's see what will change for us. So we said that we were going to mess with our x value by moving it left 3. So 0 left 3, so 0 minus 3 is -3, and then 1 minus 3 is -2. And then since our y value doesn't have an a or a k, it's just going to stay 1 and b. Let's check some values to the left and one to the right. So we've got all negative numbers here. Let's see, if we plug in a -5, my exponent -5 plus 3, so that's going to be a -2. So 1/2 to the -2. Let's pull out some scratch work if you aren't good at it yet, or I'll do it onto the sign. 1/2 to the -2, that's 2 squared, so that's 4. If we put a -4 in here, we've got 1/2 to the -1, which is just 2 to the first, or 2. And then if we put a -1 in there, I've got 1/2 to the second, which is 1/4. So let's plot these points. We've got -5, 4, -4, 2, -3, 1, -2, 1/2, -1, 1/4. Our asymptote line is where there's a k value, which there isn't one in this case. So we've got our asymptote is at y equals 0. And our function is going to get really close to that asymptote, but never touch it. And on the other side, shoot off towards infinity. Our domain on this one is all reals. And our range is everything above the asymptote, y greater than 0. Let's look at the last two. We've got a couple things happening in each of these. So our first one is a growth function, and it's got a couple things happening to the y. So first off, it's going to be reflected and stretched. And then the +1 is going to move it up 1. So let's check these out. Everything's happening to the y, mind you. So we'll use our normal function 0, 1, and actually I'm going to do it over one spot. 0, 1, and 1b. There we go. So let's see what changes. We said everything's affecting the y's, so nothing's affecting the x, so those can stay 0, 1. The y's, though, will get multiplied by -2 and then have 1 added. So 1 times -2 is -2, plus 1 is -1. B, which is 3. 3 times -2 is -6, plus 1 is -5. And then let's look over to the left one and to the right a couple. So if I put in a -1, I've got 3 to the -1 is 1/3. So -2 times 1/3 is -2/3 plus 1. And plus 1 I'm going to write as 3 over 3. So I've got 1/3 there. If I put in a 2, I've got -2 times 3 squared plus 1. So -2 times 9 plus 1. So negative 18 plus 1 is negative 17. And if I plug in a 3, I've got negative 2 times 3 cubed plus 1. So negative 2 times 27 plus 1. So negative 54 plus 1. So negative 53. All right, well, let's plot these points. We only can really plot a couple. We can't even plot these ones. They're so far off the graph. So we can plot these three. Negative 1, 1/3. 0, negative 1. 1, negative 5. And then we know our asymptote line finally is something other than 0. Our k is 1. So our asymptote line is here at 1. Y equals 1. So when I draw this, you can kind of tell it's getting closer and closer to 1 right here. And then this one will shoot out towards negative infinity. So we've got a y finally. We've got a k finally. So our domain will again be all reals. Our range is everything below that asymptote, so everything below 1, y less than 1. Our last one here, let's see, we've got a decay function. And a couple things are happening. First off, I see an h, that's going to move it left 2. And I see a k, that's going to move it down 3. So let's jump in. We've got the points 0, 1, and 1b. And the x values 0 and 1, those are going to get affected by this left 2. So 0 left 2, that's 0 minus 2. And 1 left 2, so that's 1 minus 2. And then our down 3, that'll happen with the 1 and b. So 1 down 3 is negative 2. And b, which is 1/2 minus 3. I'm going to write 3 as 6/2 here. So 1/2 minus 6/2 is negative 5/2, which is negative 2.5. Getting a little crunched, sorry. And then let's check some points to the left and right. So let's see, if we plug in a negative 4, we've got 1/2 to the negative second. 1/2 to the negative second, which is 2 squared. So that's 4 minus 3 is 1. I put in a negative 3. I've got 1/2 to the negative 1. So that's 2 minus 3 is negative 1. And if I put in a 0, I've got 1/2 squared, which is 1/4 minus 3. I'm going to write 3 as 12/4. So I've got negative 11/4 here, which I don't know what that is, but negative 3 point something. Okay, so let's plot the things we do have. Negative 4, 1. Negative 3, negative 1. Negative 2, negative 2. Negative 1, negative 2.5. And then before I connect them, let's look at our asymptote. That's at negative 3. And I'm going to get as close as I can to it, but not cross it. So our asymptote line here is at y equals negative 3. Our domain is all reals, so from left to right. And our range is everything above negative 3, so y greater than negative 3. All right, that's a wrap. So I will see you guys next time.